finding the area of a regular polygon. It sounds like we're never given enough information. Here, for instance, is an octagon, and let's say we're told that the side is of length 10, and that's all we have. How can we possibly find the area with only that? Well, the strategy is the same in every regular polygon. Divide that polygon into a bunch of isosceles triangles using radiuses of the polygon. A line from the center out to the edge is called a radius. And I've just drawn in the 8 radiuses of my octagon. Each one of those radiuses, since they're all identical, they make isosceles triangles. So here we have a little isosceles triangle, and if we could find the area of that isosceles triangle, we could just multiply it by 8, or whatever the number of sides was, to find the area of the polygon. So how do we find the area of the triangle? Well, the area of a triangle is 1/2 base times height. We've got the base of the triangle. That's just a side length, which I will call S. If we could just break into that polygon and find the height of the triangle, which I will call A for a reason you'll see in a minute, we would have it. So what I've called A is known as an apothem of the polygon, A-P-O-T-H-E-M. I think there's a G in there. I really should have looked it up before. But anyway, that's what it's called. And the way we find it is this. Inside this inside this isosceles triangle is hidden a nice little right triangle. And if we could find this angle, which I will call theta, if we could find that angle of the right triangle, then we can get everything we need, because we've got sine, cosine, and tangent, which if we have a right triangle where we have just one angle, like this one, then we can, and if we have one side length, so like if we know that x is 5, which is exactly half of 10, then we can find the other pieces with sine, cosine, and tangent. So that's the strategy. Well, how do we find theta? We find theta by using a nice simple fact about circles. Here's a hexagon. Here's the center. Here's one of our right triangles. All the way around the center would be 360 degrees. This angle right here would be 360 divided by the number of sides, 6 in this case. But in my octagon up here, I would do 360 divided by 8 to find that each one of these triangles is 45 degrees. And then to get my little angle theta, I have to cut that in 2, which unfortunately has us dealing with decimals, but that's not the end of the world. With calculators, it's just as easy. So here is our ultimate strategy. Find that little angle theta by doing 360 divided by the number of sides of a polygon. Then take what we got there before and divide it again by 2, and that gives our angle. Then we use sine, cosine, or tangent to find the apothem, which is the height of the triangle, and x, which is 1/2 of the side of our triangle, and the base of the triangle. And then we find the area of the triangle, 1/2 of base times height, and then we multiply by the number of sides of our polygon.